Welcome to the full presentation on past trends and future prospects in conceptual modeling, a bibliometric analysis. My name is Felix Härer, and together with Professor Hans-Georg, we are located at the University of Fribourg in Switzerland in the research group for digitalization and information systems. And we conduct research in these areas using modeling approaches, conceptual modeling, meta-modeling. Also, we have several technical topics, for example, data analytics, specific technologies such as blockchains, software and systems development. And given all this context, we look here at a bibliometric analysis where we conduct research on the field of conceptual modeling. However, it is not literature analysis in the traditional sense, but we try to perform a bibliometric analysis on the merits of the publications themselves, that is, quantitative research on the publications and on the actual content of the full texts of the publications, so that we try to minimize the individual choices we have to make when doing this research. I will first outline the motivation for this research. There's more specific motivations than what I just outlined, and the data collection methodology we employed. Then the results for the descriptive analysis of conceptual modeling publications. That is the quantitative analysis over several dimensions, such as geography and time, and the content-based analysis, where we look at the full texts and the topics we can identify from the full texts. And then we conclude with past trends and future prospects as far as we can derive them from the analysis. We can see that conceptual modeling in the past has been used to model various aspects of organizations, for example, products and services and processes and organization, IT services and applications, and also you will find models for infrastructure. And now with the digital transformation, the question is, does conceptual modeling support also these aspects in a digital organization? And there, these aspects might be more pronounced or less pronounced, and also the relations between them might change. For example, products and services in relation to IT services and applications might be more important. So what are the prospects for conceptual modeling in the future? Can we see maybe in the future a topical evolution to digital transformation topics? That is an open question, but we can certainly see that there are topical evolutions in conceptual modeling. If we look at the ER proceedings for 2005 and 2019, for example, we can see that we have in 2019 recent trends such as big data technology. So there are new trends appearing, but also we can note that some of these trends stay over time, and that is, for example, conceptual modeling in e-learning, which is a very current topic, maybe despite the term e-learning, and also maybe process modeling. And also we might find other topics on the left-hand side that are not as relevant today. So we will also see later on in the results of our analysis that some of the topics continue over time. Some of them are not found in recent years anymore, and of course there are also some new topics. And so what were the specific motivations for our research? First of all, there is prior work in this area where an analysis of ER conference papers has been performed between 1979 and 2005, and we want to continue our research at this point in 2005. And to our knowledge, no analysis has been performed since that point in time. Also, we found in the literature a suggestion of the possibility of a correlation between organizational cultures and the use of certain diagrams. And also there are anecdotal observations that certain geographic areas are more pronounced in conceptual modeling. And with these observations and the topical evolutions we have seen, we can really ask the question, where does conceptual modeling stand and what is its direction? And I've put our analysis motivation then in rhetorical question here. So those who remember the past can predict the future, and whether or not our analysis of the past is suited to predict the future, it might still provide some insight. In any case, we are now going to look at the actual research questions that we outline for the analysis. So in which geographical regions can we find conceptual modeling? How has the quantity evolved over time? How many authors are there, and what is their typical number of papers? What are the major conceptual modeling topics? How do they differ per outlet, and how did they evolve over time? And where is conceptual modeling positioned now? And maybe we can find indications for research gaps and opportunities. And where is conceptual modeling used maybe in the future? To attempt to answer these questions, we first collected data, and we started with the DBLP repository for computer science publications, and from it we obtained an XML dataset that contains about 4.6 million publications. We used the metadata of these publications, and here we have the conferences and journals that we selected from this DBLP dataset. That is the ER conference we can find here, and also other conferences and journals. We see here the conferences and the journals. And then we ended up with 4,131 publications. We enriched these publications with metadata that we scraped from publishers' websites and also DOI.org. That is at least the DOI URL and the author and country. So that is, for each author there is a certain country also. Then we pre-processed and transformed this data set because, for example, the information on author country is not always in a format that is normalized. So therefore we have corrected, for example, different spellings of country names, different spellings of university locations and of author names. And this is the pre-processing and transformation we applied here. We did these harmonization steps, but also we added missing data, we removed invalid entries, and we defined dimensions, that is geographical regions, including the countries and continents of authors, the dimension of outlets, and the dimension of time. Then we loaded this, and we have now 3,756 papers in an analysis database where we can perform multi-dimensional queries for descriptive analysis, that is quantitative analysis by dimension. For example, we can say we want the publications from a specific outlet over a specific period in time. Also, taking into account the publisher's data, we collected full texts, that is 3,226 PDFs. We had access to most of the full texts, but not all. These two publishers we did not have access to. And then we processed the extracted text from these publications in RapidMiner, where we performed natural language processing, that is tokenization, stopword removal, synonym replacement, and minimal stemming. And with that, we conducted several bibliometric analyses. That is an LDA analysis, TF-IDF, and n-grams. And we have the final results for the LDA analysis, but not the other two yet. So let's look at the descriptive analysis and the bibliometric analysis. For the descriptive analysis, this concerns the research question, first of all, regarding to the quantity of conceptual models over time. Conceptual modeling papers over time. And that is questions 1 and 2. And here we try to answer this question for the number of publications over time for these different time frames of 5 years. And we see that there is a steady growth, and the total number over the time span 2005-2019 is 3,199. And this is the number of publications that we also took for the following analysis in order to have the same amount of time everywhere, of course, and also because most of the publications are available then for this area. And so for these time frames, we can now drill down in a data warehouse sense into different dimensions. So let's look for this first time frame into the geographical regions and also then for the other time frames. So that is the geographical regions of conceptual modeling research. And there we ask this question and try to answer it by the number of publications originating from authors affiliated with institutions in the continents. So this means we have to consider that a paper has several authors, and each of the authors is affiliated with an institution, and the institution is assigned to a certain country. And we can see then the results for where these geographical regions are and where the research comes from here. So these are the 3 time frames, and we can see here the continents, Africa, Asia, Europe, and so on, over these 3 time frames. And note that, again, this concerns the number of publications originating from authors affiliated with institutions in these continents. And also we have to note that there are some countries which are located on multiple continents. And we note this in the paper also, and I just want to point it out here, it does not have large impact on the numbers, so we can actually interpret these numbers. Please look in the paper for details, but we can, for the European countries, for example, there is not a lot of countries located in Europe and other continents that were in the data set, so we can actually interpret these numbers. So for Europe, we have here a doubling of the numbers. For North America, it's constant. For South America, the numbers have tripled. Approximately, that is all. And for Asia, here we have seen that the numbers have almost quadrupled. So let's look at another dimension, that is the outlets. And for the 3 time frames, here outlets in conceptual modeling research over time, that's the number of publications for the top 3 outlets by their quantity. And I only have put here the top 3 outlets for space considerations. You can see table 3 for details, and the top 3 outlets in the first time frame here are the SOCIM Journal and ER Conference and Models Conference. And the SOCIM Journal has grown significantly over time. It's more than doubled. We see here 388 publications in the most recent time frame. Then we see that ER has remained more or less constant, and that there has been a decline of publications in models. Let's look at the authors in conceptual modeling and their number of papers. So now we can first of all take all the authors of all papers, and that is 5,141 in the time frame I just mentioned. And it is maybe interesting that 69% of these have exactly 1 publication, and 31% have between 2 and 61 publications. So that on its own is maybe not so meaningful. So therefore we also consider percentile measurements to get a sense for what is the typical number of papers for an author. And here we can see the number of authors and the number of publications. That is, we have very few authors that have a large number of publications. And there's been a screw observed in that 80% of the authors have less than P82 publications. So that is the 80th percentile, and so that 80% of the authors have less than 2 publications. And if we then look at the progression, we see that there's a steep increase. At the 90th percentile, there's 4 publications, and then 6 publications. And if we plot that, it indicates a power law distribution, and that you can see here on the right hand side. And also please refer to the paper for the detailed data on that. So in summary, for the descriptive analysis, we can conclude that there's been a steady growth overall for all time frames, and that concerns most outlets you can look at the individual outlets in the tables in the paper. For the authors, there's a relatively small community of core authors, and most of the 5,141 authors are not part of this core community, but they might be from collaborating fields. Let's progress to the major conceptual modeling topics in terms of published research. Here we employed a topic modeling approach, and the method is latent layer allocation, that is LDA. We used an implementation that is part of RapidMiner. It's the mallet library that is also available as a standalone library, and its implementation we used of LDA. And LDA now for all words of all documents applies a sampling scheme and learning algorithm that determines the mapping to a particular topic and weight. So that is, for one document we will have several topics, and these topics consist of words that are weighted. And to make this in any form comparable, usually when LDA is applied, the number of topics is a fixed number of topics. So we have then here 8 topics for each LDA analysis. And so this means that we analyze a certain body of papers, for example ER papers, and we have then 8 topics. We also have for papers of other outlets 8 topics, and this makes it somewhat comparable. Also we have for each of the topics then the top 5 weighted words. And we have to consider that there are of course more words in a topic, so potentially all words of all documents are in a topic, and we only here have the top 5 words. So we have to make some kind of a cut at 5 words, for example, but just be aware that there's no fixed definition of words per topic, but we say that we look at individual topics and the top 5 weighted words. So that is to say, we now identify topics, and we identify first of all the topics of the ER conference. So here are the topics, and we have 5 words per topic, and now you could look at these topics and maybe come up with a headline here for each topic. This is the data alone that you will find in the paper, and everything else is subject to interpretation. And for the purposes of the presentation, I have interpreted these topics in some way. So, for example, one could say that the first topic concerns conceptual modeling approaches in general. That is, we could expect that most papers in ER would fall in this category, and that most papers would have this topic assigned, but they would also have other topics assigned, of course. Then we have a topic databases, process modeling. That is, of course, a popular topic, as we can see also in other LDA analysis we performed. Goals and requirements, classes and types, ontologies. And here's an example for a topic that is not very homogeneous. Here we have data, user, and web. And here we have relational theory. Now we perform the same LDA analysis over all publications of the time span that I've mentioned. And here are the topics for it. We can see here already process and model. And I will also interpret now these topics. So I will say that this is the topic on process modeling, on modeling language, model transformation, software, use cases, state transition, classes and types, and databases. And so now it is maybe interesting to see what are the topics that are most pronounced for all publications, what are the topics most pronounced for the ER conference, and where is the intersection. At the intersection we find the LDA topics process modeling, databases, as well as classes and types. If we look at the topics of the ER publications, we see the ones we've just mentioned, and it might be interesting to compare the more generic topics here and the more specific topics to the ones that we find in all publications. For example, the most generic topic in ER is arguably conceptual modeling approaches, and here in all publications it might be modeling language. For the more specific topics, we can see here software and use cases, for example, and in ER we have relational theory, data, user, web, and ontologies. If we look at all the LDA analysis, what can we derive? What topics have we identified? We did identify the fundamental and general aspects of modeling in schemas. The application domain we found centered on process modeling. We found topics for specific languages and notations, and for technical aspects. We identified few topics for methodological topics, for application domains beside process modeling, and for other domains. So it's interesting to note that no specific domain is pronounced in the LDA results. And one could imagine that, for example, law, humanities, and natural sciences might be interesting application areas for conceptual modeling. From other LDA analysis that you can find in the paper, we can observe over time that model transformations have been of constant interest, that fewer publications on software models can be observed in recent years, and more publications on process and business information systems modeling can be found in recent years. Also, for regional differences, we compared North America and Europe, and we can find that modeling tools, goals, and requirements are stronger in North America than in Europe, whereas processes, database, and data schemas are stronger in Europe. Comparable are software data and transformation. And note that these trends are only really meaningful if we consider the sample that we have for conceptual modeling a good sample. And so therefore, we look here at the limitations. We believe that the data set is a good sample. However, we need to consider that there's varying data availability per outlet, for example, fewer recent models publications. We have made interpretations, at least in the presentation, for the LDA topics. The actual data in the paper, that does not concern. And we made a selection of only a subset of outlets for publishing research. We only included English language publications. We did not include workshops, and we did not include publications in domain-oriented outlets. To conclude, what are the past trends and future prospects that we could identify? We could identify the major conceptual modeling topics, and these seem to be well established. LDA indicates the focus on the fundamental modeling topics on processes and information systems. We did not find application domains and specific fields, and it might be reasonable then to suggest the broadening of the topics for major outlets, for example, in regards to humanities, natural sciences, and law. And it might also be reasonable to suggest to make conceptual modeling more accessible to other fields, where there exist a lot of domain experts that might not be experts in computer science or information systems, but they may benefit from conceptual modeling methods, and it might strengthen the impact of conceptual modeling. Our next steps are to design and conduct tests for the interpretations that we have made, to generate hypotheses, and maybe conduct more targeted analysis for these results and for the identified topics, and again interpretations on these topics. And then also we want to extend the analysis method using more semantic approaches, for example, to find out what are the relations between different topics that we could observe. I thank you for your attention.